Welcome back. In previous two videos, we talked about 1.1 and 1.2, along with some justification about rescaling business. Now in this video, we're going to talk about the next three problems, 1.3, 1.4, and 1.5. If 3% of the automobiles travel faster than 72 miles per hour, what is the standard deviation? It asks. Problem 1.1 and problem 1.2 are both based upon the standard deviation was about 4.95. 1.3, we no longer assume that, and we're trying to find out the standard deviation with other informations. So how do we start this problem? As usual, draw the picture. Well, here's the picture. Outline is the normal curve like this, going up and down. Center, 62 miles per hour. The problem explicitly said 72 miles per hour, so that's the end. And how do we shade? Well, it depends upon what we want. 3% of the automobiles travel faster than 72 miles per hour. So travel faster, more than 72, so we have to shade this time to the right hand side. So we are looking for this right hand side, this red part. And that probability is what? 3%. In decimal, 0.03. So this is 0.03. Consequently, the left hand side is what? 0.97, isn't it? Yes. And that left hand side is important because your normal table is based upon the left hand side. Let me show you that normal table again. You see this picture here? Shaded to the left. Shaded to the left. So all the numbers here are based upon shading toward your left. This problem is about shading toward the right. So we want the other one. This was 3%, so the other one was 97%, and that is the starting point. So we are looking for 97 percentile is equal to 72. From that, we have to find out the standard deviation. What formula do you use? Again, the same thing. Z equals x minus mu over sigma, or n minus center over standard deviation. Well, here we go. X minus mu over sigma, but more practically, n minus center over standard deviation is the z-score. What is the end? 72. What is the center? 62. You see, if you don't draw the picture, it's very hard to get all these numbers in. If you draw the picture according to all these steps, outline, center, and shade, it's not difficult to put in all those numbers into this formula. End is 72, center is 62, and standard deviation unknown. And how about the z-score? Well, from 3% to the right, from 97% to the left, we have to find out from the z-table. If you do it, you're gonna get about 1.88 something. Well, let's find out, is that what we are going to get? Let's look for 97%. Well, all these are pretty small. Let's go to the second page here. 97%, 0.97 something, and oh yes, this is the closest, 0.9699. This one, 0.9706. Fairly bigger than this one, so I'm gonna select 1.88. So 1.88. So 1.88 is what I'm gonna get from this z table if you do just table method and some estimation. Of course, Mathematica can do better. Based upon something like 12 or 13 decimal digits, we end up with a little bit more accurate number. So let's use a little bit more accurate number. In reality, you're going to be using 1.88. All right, do you have an equation now? End is 72, center is 62.0, And sigma, we have to find out the denominator, and z-score 1.88. We have an equation, one unknown and an equation. We have to solve it. How do we do that? Well, pretty simple. If you just multiply sigma to both sides, this will kill the left-hand side, and we'll have this times sigma, and divide by this number will go down. What happens is switching this denominator and this numerator, and that's what we have over here. Punch your calculator in, you're gonna get 5.3169 approximately speaking. Well, standard deviation of about 5.3 was 5.32 miles per hour. Okay, for the next problem, we'll have to use 5.32 miles per hour or 5.317 miles per hour. Problem 4 said, and using the standard deviation found in 1.3, which is 5.317, I forgot already. Amazing. 5.317, yes. So 5.317 for this problem, 5.317 for that problem. Do we have enough time? Yes. Okay, let's go ahead with 1.4. Find the proportion of the cars that are traveling faster than 55 miles per hour using the standard deviation of 5.317. Well, here we go. First, draw a picture. And 55 miles per hour, that's a little bit less than 62, so on the left-hand side. And traveling faster than, so you have to shade to the right. Just follow this process. Outline, center, and shade. We have that. And we have to find out this probability here to the right using the denominator is 5.317. Well, here is the computation. N minus center over SD. And N is 55, center is 62, and the denominator, standard deviation, 5.317, as we calculated in the previous problem. Run your calculator, you're going to get something like this, negative 1.31 something. And looking up the probability for z-score for negative 1.32, let's go ahead and do that. Negative 1.32, you're going to get the probability to the left. Negative 1.32, where is it? Negative 1.3, you have to look at this column, and 32, so here, 0.0934. So that is the probability. So 9.34%. Is that the answer? Actually, no, not really. We just found out this probability to the left. Let me bring back that normal table. You see all those numbers associated to this shading toward the left. Toward the left. But how did it shade in step 1? You shade to the right. So what do? Subtract from 1 because the total probability is 1, and that's how you're going to get this probability here. 1 minus the 0.9 something, and we get 90.6, something like that. So 90.6% of the cars are traveling faster than 55 miles per hour. Alright, now let's go to the final problem. Find the 95th percentile using the standard deviation we found in 1.3, which was 5.137. Was it? 5.317. Okay. As usual, draw a picture. Outline, center, and shade. Outline, normal picture, good. Center is 62. And we are looking for 95th percentile. So it should be pretty high so that the shaded area is 95% or 0.95. We are looking for this x value using the denominator sigma as 5.317. How do we do that? As usual, we put everything into this formula. Z-score is n minus center over SD, and SD is 5.317, and center is 62. X value, the n, we don't know. Excuse me. But we can find out the z-score. And what is the z-score associated to 95%? Well, let's go to the second page. That's where all those high probabilities are there. Where is 0.95? Here. We have these two. 0.9495, 0.9505. Again, these are pretty much push. So I'd rather estimate it as 1.645. 1.645. Here is the real quantity obtained by Mathematicas computation based upon 12 decimal digit. 1.64485. It's remarkably accurate. So in reality, you're going to be using 1.645 like this, and then do the computation. But at this moment, we have more accurate number here, so let's take advantage of it. Let's solve this equation. How do we do that? Flip this denominator to the other side by multiplying. That's what we have over here. And flip this subtraction by adding off to the other side. And that's what this computation is all about. Run your calculator in, you're going to get 70.74. So the 95th percentile is therefore about 70.75 miles per hour. Okay, so much for problem number 1. Problem 2 will be discussed in the next video.